In this question, 27% of all Oxnard students major in STEM. Let X be the number of STEM students if 50 Oxnard students are randomly selected. The first thing we would like to figure out is the distribution of X. Now, when we ask a student whether they are STEM major, they will either say yes or no. And there will be discrete number of students who are STEM major, which means we could have 0 STEM major, 1 STEM major, 2 STEM major, or 25 STEM major, but we could never have 2.5 STEM major. So what we have over here is binomial distribution. Binomial distribution is discrete. With the parameter, so the parameter we want to enter over here is MP. N is the total number of trial. In this case, we are going to ask 50 students. And P is the probability of each student being STEM major. And we would like to express the answer in decimals. The first question is exactly what is the probability of exactly 11 of them major in STEM? So we're looking for the probability of X equals 11. And because we have equal sign, I'm going to use this function from your graphing calculator that is called binom PDF. We use binom PDF. Let me pull out my highlighter. We use binom PDF. Just going to highlight that P when we have equal sign. And the syntax for binom PDF is M P X. That's why I have you enter the parameters up there, because now all you have to do is look up, and we know that N equals 50, P equals 0.27, and X equals, that is this number over here, equals 11. Okay, now let's pull out my graphing calculator, and I'm going to go to second VOS and scroll it all the way down until you see binom PDF. Do not choose CDF. It makes a huge difference, and you will see that. So binom PDF 50, comma 0.27, comma 11. Close the parenthesis and enter, and that is my probability. So let me report that to 4 decimal places, and that is 0.0970. Okay, so that is the probability of exactly, and we use binom CDF. The next question, I would like to know what is the probability of, at most, 16 of them are STEM major. So at most means X less than or equal to 16. And when we have less than or equal to, we will use this function over here, binom CDF. And the syntax is MPX. So let me highlight that when I have less than or equal to, I will use binorm CDF. And n is 50, p is 0.27, and x is 16. So let me pull out my calculator, and I will go to second VAS, and choose binorm CDF. 50, comma, 0.27, comma, 16, close the parenthesis. And that is my probability. It's 0.A311, if I remember that correctly. Okay, so two functions, binorm CDF and binorm PDF. Now let's look at the next question. What is the probability that fewer than 16 of them major in STEM? So we're looking for the probability of x strictly less than 16, which is probability of x less than or equal to 15. Why do I want to make that conversion? That is because when we have less than or equal to, and only when we have less than or equal to, we could use binorm CDF. Why is x strictly less than 16 equivalent to x less than or equal to 15? Because x is discrete. We could have 15 students, 16 students, 17 students, but we cannot have anything between 16 and 15. So strictly less than 16 is equivalent to less than or equal to 15. And from here, all you have to do is use binorm, CDF, and n is 50, p is 0.27, x is 15. And I calculate that in advance, and the probability was 0.7425. Okay, 3 inequality down and one more to, oh, looks like actually 2 inequality down and 2 more to go. Trying to cover all different cases, so when you transition to your homework, you will have an easier time. So in this case, we would like to calculate the probability of x strictly greater than 16. Now, I could use binorm CDF if and only if I have less than or equal to. And here I have strictly greater than. So I have to convert this inequality. So instead of having greater than or equal, strictly greater than, I want to have less than or equal to. But because I flipped the sign, I'm actually taking the complement. That is a concept we learned a few weeks ago. To take the complement, we need to subtract it from 1, and we calculate the probability of x less than or equal to 16. So all I did was I flipped the inequality, and because I'm just going to use a highlighter over here, because I do not have equal sign over here, I need to include the equal sign with this inequality. And make sure you also include 1 minus in front of this probability because we are taking the complement. And from here, notice that this is really just 1 minus binorm CDF 50.27 16. You could go ahead and type that into your calculator, or you could use the fact that we already carry out this calculation up here. So we could go ahead and subtract 0.8311 from 1, and that would give us, let me see, 1689. Oop, something was missing. There should be a 1 over here. It ran away. The 1 ran away. Huh, how funny. Okay. I'm just going to move the cursor over here, otherwise it will do weird thing in a minute. Okay, next question. Let's calculate the probability of at least 16. So that will be the probability of x greater than or equal to 16. Once again, we're going to use complement to convert this inequality. So we will have 1 minus x strictly less than 16. The reason for that is because we have equal sign over here, so we won't include the equal sign over here. And one more step, that is equivalent to 1 minus the probability of x less than or equal to 15. That's what we cover right over here. So you should be able to find that probability by yourself. Now let's look at the very last part of this long question. We want to know the probability having between 14 and 18 students, and that is including 14 and 18. So we're looking for the probability of 14 less than or equal to x less than or equal to 8. And that is equivalent to, now once again, I want to rewrite this inequality because I want to use binom CDF. That is equivalent to x, probability of x less than or equal to 18. Now, if I only have this probability, that will include everything from 0 to 18, but we only want to include everything from 14 to 18. So I need to subtract everything from 0 to 13. So to remove the first 13 numbers plus 0. So 0, 1, 2, 3, 4, 5 until 13. So from here, you will be able to enter the answer into graphing calculator. So we will have 50.27, 18 minus binom CDF 50.27 and 13. And type that into your calculator. And let me see if I carry out this calculation myself at any point. Oh, I did. And I have the answer right over here. It's 0.4311. And I actually also have the answer for this one. That is 0.2575. Let me verify. So this plus this should give me 1. That looks like the case. Okay, so this is how do you apply two very important functions, binom PDF and binom CDF, for binomial distribution. Of course, those two functions are only useful if you have binomial distribution. This is the end of my recording. If you have any questions, please do not hesitate to ask me.